So we've talked a little bit about the quantitative aspects of uncertainty, a little bit. We'll get a lot more into it in this class. But I'd now like to talk about how we sort of classify error. So as I said at the beginning of this chapter, we know that error is present in basically any measurement that we make. So we want to know where that error is coming from, and there's two broad types of error. So one is systematic error. So this is something that is caused by a flaw in the equipment or in the design of the experiment. The key point about systematic error is that it's reproducible. Right? The error is present every single time you make the measurement and occurs in the same way every single time. In theory, this error can always be corrected for. If you know the error exists and you can correct for it, if you know the error exists, you know how big it is, and you can measure it, then you can correct for it and eliminate this type of error. So an example of something that might be something that's systematic error, and we'll take some time in class to discuss this in more detail, would be, say, I'm thinking of some very precise spectroscopic measurements that I'm familiar with, where they correct for things like the Earth's gravitational field affects, how their instruments work, or things like a miscalibrated sensor, right? So maybe you have a thermometer that always reads 2 degrees too high. One key thing that you'll notice about systematic error is it's always positive or negative relative to what you know to be the correct value, right? So something like a thermometer that just the calibration is off and it always reads 2 degrees too high. Or like my car, the speedometer in my car, whenever I go past, in front of the college, at least right now, there's a thing that measures how fast you're going and shows you on the sign. Those don't match up between my speedometer in my car and what's displayed. My car, shows a couple miles per hour faster than what's displayed on the sign. So there's a systematic error of some kind in there. I don't know whether it's with my car or with the radar device, but one or the other is off. Okay, the other type of error is known as random error. And random error comes from things that you can't control. So it's not reproducible. That's what really differentiates it. And you can't really correct for it. It's just always there and present. And this comes from uncontrolled things in the experiment. So some of the things that we often don't control about an experiment that may affect our measurements, maybe changes in temperature or pressure could affect our results, which could lead to things like expansion and contraction of metals or glasses that slightly change volumes and things like that. Electrical noise from maybe other pieces of equipment or the power in the building or noise spikes, things like that. These are things that you can't really correct for, and random error, is, for example, where you see that the last digit of a value you're measuring on a voltage or something like that it changes a little bit over the course of time, right? And so random error is something that we always live with, we always deal with, and is something that that you can never completely get rid of. You can try and get rid of more of it by controlling more and more things about your experiment, but there's always a limit.